SNS College of Technology. In this lecture series video of electric circuit analysis, today's topic is about Thevenin's theorem, problem based. So problem number 3. So previously we have discussed two different types of problems which employs the Thevenin's theorem, applications, formulas and everything. So in this problem number 3 we are going to determine the current I in the network using Thevenin's theorem. So based on the first problem, we are having the same similar question. So there we can find out the I value. So here also we are going to determine the I value in the network by using the Thevenin's theorem. The circuit diagram consists of resistance, 3 types of resistance, 2 types of voltage source. There is no current source present in this circuit. So we are already know that in Thevenin's theorem we have basically 3 rules. So open circuit the resistance, load resistance, open circuit the current sources, short circuit the voltage sources. But here we don't have any current sources, so we need not to open circuit the current sources. But we are having 2 types of voltage sources, 3 types of resistance sources. So here this resistance is a load resistance where the I is flowing through it. So we are going to find out this I value and the load resistance. Here we open circuit the resistance value. So for finding out the IL value, we know that Thevenin divided by Thevenin plus RL. So step number 2, we are forming an equivalent circuit where consists of Thevenin, Thevenin, RL values. So RL load resistance, we know that 10 ohms. In step 2, so the load resistance is removed because of we have to open circuit the resistance value. So the 10 ohms resistance is open circuited, and the also current across these circuit is mentioned as A and B, where Thevenin is employed. So these two values we are finding out the I value is equal to 12 minus 10 divided by 4 plus 6 is equal to 0.2 amps. So I value we find it out 0.2 amps. So Thevenin is equal to VAB minus so VAB. So VAB is equal to 61 minus 12, where we can get 6 into 0.2 minus 12 is equal to minus 10.8 volt. So for calculating the Thevenin's value, we have to solve these resistance values. So basically these two values is connected in parallel. So we have to employ the parallel formula where R1 into R2 divided by R1 plus R2. So 4 and 6 values is connected across parallel. So we apply this 4 into 6 divided by 4 plus 6 value. So solving these we can get RL is equal to 2.4 volts. So by applying these values the load current is determined. So come to the first formula, we know that IL is equal to Thevenin divided by Thevenin plus RL. So RL is employed here. So Thevenin value is 10.8 and Thevenin is 2.4 plus load resistance is 10. By solving this value, we can get the current value as 0.871 amps. So here, determine the current I in the network using Thevenin's theorem. We find it out I value is equal to 0.71 amps. So okay, so solving this problem, solving previously 2 problems, totally 3 problems, we have an understanding of what is Thevenin's theorem. So we are using n number of applications. We are using this Thevenin's theorem in lot of circuits to analyze the load current, Thevenin's value, Thevenin, resistive load and IL, PL, etc. So applying this Thevenin's theorem, we can find out lot of networks which is 2 loops or 4 loops or n number of loops we can find it out. By using this Thevenin's theorem, we can apply lot of maximum power transfer theorem, reciprocity theorem and n number of developments. So these are all the things which comes from the mesh analysis and applying KVL. So preparing about this Thevenin theorem, we have to be clear about KVL. So KVL is nothing but your Kirchhoff's voltage law. So Kirchhoff's voltage law, we have to find out the voltage and current values by using the Cramer's rule, by forming a 3 cross 3 matrices or 2 cross 2 matrices. So by here we are short circuiting, open circuiting and removing the load resistance. So if the resistance is connected across the voltage source in parallel, we have to short it out, and all those formulas and all those theorems are used to employ all these theorems. So by applying this, we can find out the large amount of transmission line problems. So by applying Thevenin's theorem, we have to find out the voltage value in the large amount